Why, hello, and thank you for tuning in to another episode of The Spiritual Scientist, and I'm Victor. Thank you so much for tuning in. Now, it's a little late in the evening here, but I wanted to do a video. I haven't done one in a while. I've been meaning to do one, but to tell you the truth, a lot of this freaks me out sometimes. So I have to gather my wits together and my courage. And I felt like doing another one. And this one, let's just say, popped up. So this one's going to be on a couple of subjects. Anticrepuscular clouds. So what's an anticrepuscular cloud? Perhaps you haven't heard of this before. I didn't until this morning. An anticrepuscular cloud, and I'll illustrate it in a video, in a picture rather, and perhaps I'll show you a little video. So it looks like, So the interesting thing about these anticrepuscular rays is what you're going to see is they're the exact antipolar to where the sun is. So we have the sun on one side. I guess that would be a sunset or a sunrise, and then on the other side we have an anticrepuscular ray. So how does that make sense? So you have anticrepuscular, and let's see if I'm saying it right, anticrepuscular rays. Now you have these rays that kind of, what I'm saying is they converge, and they're converging together on one side. You're looking at the sunset, and those rays from the sun are spreading out, and you turn around, and on the other side the rays are converging into a vanishing point, and you're saying to yourself, sure, that makes sense. Well, I mean, maybe I'm not the sharpest tool in the shed, but I thought rays of light go actually straight. So how could it be that the sun comes from a point and it shoots out, it seems to come out in an angle to you where you are, and when it goes around you, then those rays kind of converge? The news articles that talk about it don't make much sense either. So maybe one of you is a scientist and like to explain to a simple-minded guy like me who's, I have studied a lot of things, so I kind of do know my stuff. So I'll read it from Wikipedia, which isn't really the best of sources. Sorry, Wikipedia. But we know where you get a lot of your information from. But anticrepuscular rays or anti-solar rays are meteorological optical phenomena still similar to crepuscular rays, but appear opposite of the sun in the sky. Anticrepuscular rays are essentially parallel, but appear to converge toward the anti-solar point or the vanishing point due to a visual illusion from linear perspective. I don't know about you, but I don't think I have a visual illusion from linear perspective. I mean, being that I have a perspective, in my perspective, I guess you could call it linear, but that makes no sense to me because I can see a straight line going past me. Now, if you see a railroad tracks, they seem to converge together in the far distance. But why would we see sunlight bend towards, unless you're in a dome? Now, if you were in a dome, for instance, that would make more sense because those lights would seem to, if you were in the middle of a bowl, then the lights would come from one side and seem to, converge in the other. Well, that would make sense if you're in some kind of bowl or a dome. But, seeing sunlight, you're not going to see the light bending around. And I have to mention, I looked at a lot of sunrises and sunsets, and I've turned my head around when they're going around, and when sunlight's leaving or coming up. I mean, I've been on this earth for quite a while, and I've never seen any of these convergence of light taking effect. So this, to me, would go into the category of Mandela Effect in a big way. Now, they're saying anticrepuscular rays are sometimes seen enclosed by a rainbow. In this case, they'd be called wagon wheel spokes. So how could they be in a rainbow? What are you talking about, Wikipedia? That does not. So let's read what else they say. Anticrepuscular rays are most frequently visible around sunrise or sunset. This because the atmosphere light scattering that makes them visible is larger for low angles to the horizon. Backscattering, see Milli theory, than at most other angles. Anticrepuscular rays are dimmer than crepuscular rays because backscattering is less than forward scattering. I think that's a bunch of baloney. Miley theory. So anticrepuscular rays can be continuous with crepuscular rays curving across the whole sky in great circles. So we don't just have light that's coming from the sun, going past us. Now they're going around. Now the light's, going around in great circles. So, what the heck, right? So let's look at Miley scattering. The Miley solution of Maxwell equations, also known as Lorentz, which I do know Maxwell equations, also known as Lorentz-Miley solution, which I've never heard of. The Lorentz-Miley-Derby Debye solution, or Miley scattering, describes the scattering of an electromagnetic plane wave by a homogeneous sphere. The solution takes form of an infinite series of spherical multipolar partial waves. Is named after Gustav Miley. The term Miley solution is also used for solutions Maxwell equations for scattering by stratified spheres or by infinite cylinders or other geometries where one can write separate equations for the radical angular dependence of solutions. Sounds like a bunch of baloney so far. The term Miley theory is sometimes used for this collection of solutions and methods. It does not refer to an independent physical theory or law. No kidding. So let me translate this for you. What they're saying is they're saying a bunch of words and saying at the end that it doesn't really mean anything, and there isn't really a law, physical theory, but that's what this is saying. More broadly, it says Miley scattering suggests situations where the size of the scattering particles is comparable to the wavelength of the light rather than much smaller, much larger. So what you're saying is, from our point of view, we can actually determine with the naked eye the wavelength of the light coming from the sun and see it maybe in the wavelength. What they're saying is slowing up or speeding down, and we could determine that by just turning our good old head around and seeing it as on the horizon, see all those lights kind of converging is what they're trying to say here. Miley scattering, sometimes referred to as non-molecular or aerosol particle scattering. So they're trying to blame it on chemtrails. Is that what you're trying to say? Takes place in the lower 4.5 kilometers of the atmosphere, where there may mainly essentially spherical particles present with diameters approximately equal to the size of the wavelength of the incident energy. Doesn't really say much there either. Mildly scattering theory has no upper size limitation and converges to the limit of geometric optics for larger particles. Makes no sense. I'm sorry. Um, so they're going to say, I'm reading ahead a little bit. They just talk about wave functions. Doesn't really boundary. By enforcing the boundary condition of the spherical surface, the expansion coefficients of the scattered field can be computed. What boundary condition of the spherical surface? I guess what they're trying to tell you here in a gentle way, is that you're in a dome and that the light is bending around in the dome. There's no other way to say it. You're not saying that the earth is round, because why would the earth, the atmosphere of the earth would not be bending the light around. Now the only way that could happen is if the gravitational field was so strong on the earth that it would actually bend the light. That would happen if we were, the gravitational field of the earth was going towards that of a black hole. Okay, I do happen to know what I'm talking about. So they're giving you computational, it says computational codes, like that's going to intimidate me. The Miley solutions are implemented in a number of programs written in different computer languages, such as Fortran, MATLAB, and Mathematica. These solutions are in terms of infinite series and include the calculation of scattering, phase function, extinction, scattering, absorption efficiencies, and other parameters such as asymmetry, parameter, or radiation torque. Current usage of a Miley solution indicates a series approximation of a solution of Maxwell equations. There are several known objects that allow such a solution: spheres, concentric spheres, infinite cylinders, clusters of spheres, and clusters of cylinders. There are also known series of solutions for scattering ellipsoid particles. For a list of these specialized codes, examine these articles. So it points you to some other articles. Codes for electromagnetic scattering by spheres. And it's giving you, actually down further, it gives you Rayleigh scatterings, describes the elastic scattering of light by spheres that are much smaller than the wavelength of light, the intensity of the scattering radiation. Reading through the equation, it says here that the particle size becomes larger around 10% of the wavelength of the incident radiation. Makes no sense. Blue sky, blue. Okay, so I mean, I'm reading through this for the first time with you, and they're showing the mathematics. What they're basically saying is light goes around in the dome. That's the only way that makes sense, but they're saying it's such a complicated way that they're trying to make you basically not know it or not go through it. There's something here, I go back one, now it says where it wasn't there before, a mountain shadow. A common example of a single anticrepuscular ray is provided by the shadow of a mountain at sunset. When viewed at the summit, it appears to be triangular, whatever the shape of the mountain, with the apex of the antisolar point. So I just looked through this, and that wasn't there a second ago, and now it's there. So there you go. Anticrepuscular rays appear to converge in an antisolar point. So what they're saying is, here's the sun. Here's you as observer, where my nose is. And here is the other away from the sun. So the sunlight sunlight's coming out like that. It's going around you, but then it's converging for some reason. It's not what you would think is light comes from the sun and it would just straight on go on as it has in my whole lifetime. But now we have it going, the light's, bending around. We also have something I just saw, we know about, you've heard about the moon bows, right? So we have a moon bow. Let's look at a recent, I started looking at anticrepuscular rays. NASA just came out with something. Okay. And they're saying, here, anticrepuscular rays converge opposite of the sun. Okay, so that's what I'm talking about. So now when you go and look at the rays of the sun, you turn around and you're going to see this now on the opposite side. When you turn your head around, this isn't the sun. This is where the sunlight's going from the sun. Now it all converges together. Is there anything interesting to see in this direction opposite the sun? I'm reading from the article. Sometimes there is. Notable items include your own shadow, a shadow of the moon during a solar eclipse, a full moon, an eclipse of the alignment's good enough, a full Earth, planets at opposition, glints from planets, the Genjin from interplanetary dust, the center of a rainbow, Hall of Mountains fog bows, an airplane glory, and something yet again different if your timing, clouds and sun position are just right. So we now have something called an airplane glory. I don't know if you've heard of airplane glories. I haven't until when I started looking at these, and I've never heard of a mountain fog bow before. So just thought I'd bring these up. So mountain fog bows, Jin sheen from interplanetary dust, and now we can see the center of a rainbow. So let's look up, I never heard of this before. Jin sheen. Who came up with this word? Jin sheen. Sounds like a BattleBot. Jin sheen. A patch of very faint nebulous light, sometimes seen in the night sky opposite the position of the sun, is thought to be the image of the sun reflected from gas and dust outside the atmosphere. So what they're explaining to you is that now a patch of very faint nebulous light is seen at night when you turn around from where the sun is. Now you can see, now they're seeing that the sun was there, but now what you're seeing is this, I guess. So you're seeing this. The sun was there before, I guess, on the opposite side, but now you're seeing a Jin sheen. Gengenschien. Jin sheen. I think I'm spelling that right. So there we go. So now we're seeing Jin sheen. So even when the sun's not there, you're seeing a reflection of the sun on something. It seems like we're in a dome, where we weren't in the dome before, but now we're in a dome. Jin sheen. Never heard of that. So let's look up what was it? A moon bow? No, it was a mountain bow, wasn't it? Mountain bow. Mountain shadow bow? Oh, it was a fog bow, sorry. Mountain fog bow. Anyone ever heard of that before? Whoa. So now we have these mountain fog bows. Say hello. And Mountain fogbow. Mountain fogbow. Pretty cool. Mountain fogbow. I don't mean to alarm you. I don't mean to scare you. And I don't mean to frighten you. Just thought I'd show you. Now we have something called a fogbow. There's our... Hey, it's not a rainbow, it's a fogbow. And now we have a certain number of rainbows or extra rainbows. I think I talked a lot about rainbows before. But there's some new types of rainbows. Oh, when you thought you had these, the rainbows down, there's even more rainbows than types of rainbows. So rainbow types. You know what really got to me today? I was reading about the higher order rainbows. Wow. There's monochrome rainbows, supernumerary rainbows, full circle rainbows, multiple rainbows, twinned rainbows. Twinned rainbows are some of the rarest types of rainbows. Reflected rainbows, higher order rainbows, let's not forget the moonbows. Rainbows under moonlight. The higher order rainbows are really interesting, though. They're all interesting. There is a reason I'm talking about rainbows, and I'll get into that in the next video, why these Mandela effects kind of come up certain ways. You'll be interested in watching the next one. A rainbow is a meteorological phenomenon which has awed humanity with its beauty throughout history. A rainbow is a form of light traveling through the atmosphere, interacts with water droplets. We know all this. Thank you. Twinned rainbows are some of the rarest types of rainbows. Sure, they're rare. Come on. Rainbows are rare. When I remember rainbows being rare. Now we have primary rainbows and secondary rainbows, multiple rainbows, full circle rainbows, supernumerary rainbows, monochrome rainbows. So let's go to higher order rainbows. That sound really spiritual. A rainbow order is a getting tired. A rainbow order is a characteristic which is used to categorize rainbows into two basic groups, primary rainbows and secondary rainbows. The main determinant of a rainbow order is its number of reflections of light and water droplets involved in the formation of a rainbow. Primary rainbows are also known as first order and are formed from one light reflection, while secondary rainbows, also known as second order rainbows, are made from two reflections. There are other rainbows which are formed from more than two internal reflections, and these are also known as higher order rainbows. The number of internal reflections is not limited and runs to infinity. But the higher order rainbows become less visible as the number of internal reflections increase. Wow. We're talking about rainbows that go into infinity. Higher order rainbow. So a lot of people, it's been co-opted. A lot of things about the rainbow. What does the rainbow mean? Well, in the Bible, it means that was a promise that God wouldn't destroy the earth with water, with a flood again. So that's how we got the rainbow. So in biblical terms, the rainbow is actually is God's promise. God's promise to the people that he wouldn't destroy the earth. So what we're looking at when we see these kind of rainbows is in a way, what you're seeing is God's promise. And it's God's grace. So he's showing you and me, he's showing that through the rainbow, it's a reminder of God's promise. He's keeping a covenant. So he's keeping a covenant with people and himself. So that's what that is. But now we're getting all these different types, so it's very, very interesting. I'm going to let you ponder this tonight. Thank you so much for your time. I know your time is valuable, and I try to keep these things short. I haven't said anything tonight, but I'm reading from scientific articles from the latest things that have changed for me personally. And if it hasn't changed for you, I appreciate that. There's also some other Mandela effects I was going to talk about. I'll try to bring up. There's a new. There was a. I read the article real quick, but there was a. They found a patch. I believe is in Peru. Is it? And if anybody's interested, I'll comment where it is. I'll copy the article where they found insulated from time about 300 extinct species in one valley. All these different lizards and snakes and things, and everybody said they were extinct for thousands and tens of thousands of years, and all of a sudden there was just a group of them, now all together, where they had all these different types of animals that they just kind of popped up, and here they are again. I find that very interesting. Well, thanks again for your time. Love goes out to everybody. Like, subscribe, share, as it were. And if you're interested in seeing more, say, I want to see more of you, Victor, more of your spiritual scientist channel. For some of you, it's your first time watching my channel. I thank you for tuning in. For others that are longtime viewers, thank you so much. And, for the new people, welcome aboard the crazy train. I think you'll like what happens with me. And thank you so much. Have a good day. Bye-bye.